Hello guys, this is me again. Thank you for listening to my lecture series. My name is Joseph AGK or G. I'll be teaching you expectation or expected value for random variable. So basically, this topic can be applied in different areas of human endeavor. Have you asked yourself, why do some people who live in a different zip code pay different amounts on their insurance premium? The reason is because the insurance companies have already factored in the probabilities of you or your car being in a risky area, or being involved in an accident or theft. So for these risks, some locations and zip code have higher risk. So people in those zip code or locations pay higher premium on their car insurance, even though they might have the same or similar driving records. Okay. Anyway, this is where this kind of thing can be applied, expectation. You can also apply this principle in business and finance to find out if a business will be profitable or not, or even in lottery. The examples I will give you here, I will apply it to lottery and business. Lottery, I started with lottery to show you that basically when it comes to lottery, you should expect to lose. However, if you are lucky to win, congratulations, okay? But for business, you can apply this principle, and I'm going to show you how in this topic, expectation or expected value of a discrete random variable. Let's begin. Now, expected value or expectation is a name that we give to the theoretical average, the average of that variable. So the formula we use is here. Ex, which means expected value of x, where x is the random variable or the discrete variable we are talking about, equals the average. This symbol here is the mu, represent average. Sum of x times the probability of x. So you multiply all the variables that x will have with their corresponding probabilities. Then after that, you add them to get the expected value or expectation or the mean. Okay? Now, so that's basically what it is. That's what we're doing when we do an expectation or expected value. Now, remember, probabilities can never be negative value. I mean, the probability of an event occurring can never be negative and can never be greater than 1. But the expected values can be negative or greater than 1. Okay? Look at this. Let's look at this example. It says, this example has to do with lottery. So I'm going to show you why you all usually fail. Like I said, when you buy a lottery ticket, always have the mindset that you will lose. It is better that way, so that if you lose, you will not be disappointed. But if you win, good luck, congratulations. So, but most time we lose anyway, because of the fact that the system is structured to favor the house. We the players, we don't have any chance. So if you win, it is pure luck. And of course some people are lucky enough to win. Anyway, back to our work. A raffle ticket. So a raffle, 15,000. At a raffle, 1,500 tickets are sold at $2 each for 4 prizes. Here are the prizes: $500, $250, $150, and $75. You buy one ticket. What is the expected value of your gain? Okay, what will be your gain? Now, to find this, first of all, let me explain one thing that is very important. Suppose you bought a ticket and you won $500. Of course, they will give you a check for $500. Sure, but actually your real win is $498. Why? Because they will not give you the $2 that you paid already for the lottery. So that means that their net gain will not be $500. You have to subtract that $2 to get your net gain, which is what I did here. So that means somebody who won $500, his actual win is $498 after you minus the $2 that they paid to buy the ticket. And somebody who won $250, the actual win is $248 because you have to subtract the $2 that they paid for the lottery ticket. Now, there are 4 prizes, which means that the probability of winning each of those prizes is 1 out of 1,500 tickets. See, look at it. It's a 1,500 ticket we are sold. So for you to win this prize, it is only 1 ticket that you bought that will win this prize. So you have 1 out of 1,500. So that means probability of winning is 1 out of 1,500, which is 0.001. So how do I get 0.001? Okay, I got it with my calculator by doing okay, let me turn it on. Okay, clear it. This one here, 1 divided by 1,500. Okay, 1,500. That give me 0.00006. So when you round it up to 3 decimal places, give you 0.001. Okay, so the first thing we do is to prepare our table of values for these winnings prizes. So like I have already mentioned, if somebody who won $500 actually won $498, and the probability is 1 over 1,500 over 1,500. So this is for somebody who won $500. The chance of winning is 1 out of 1,500. For the person that won $250, the net win after you subtract the $2 prize is $248. You can see it right here, and the probability is again 1 over 1,500. So you follow it for all the 4 prizes. Now, in most cases, you lose. Remember, so you can lose. That means we use negative $2 to represent the loss if you didn't win. And now you have 4 ways of winning. So how many ways of losing do you have? Remember, there are 1,500 prizes, and you have 4 ways of winning. How many ways of losing? So you have 1,500 minus 4 ways of winning. So you have 1,496 ways of losing. So you can see right here. So the chance of losing your $2 is $1,496 out of 1,500. That means 1,500. So you can see that you have a higher probability of losing than compared with winning. Now, having put it in this form, we are ready to calculate the expected gain. Remember, the question says, what is the expected value of your gain? So let's calculate it. So we now I'm using the shortcut method. This side, I put all the prizes that you can win, 500, which give you a net gain of 498 if you subtract the lottery prize. Then 250, 150, 75. Then of course you lose sometimes, which is negative 2. So I've already calculated the probability of winning in my previous slide. You can see right here, which is 0.0001, right? So for each of these prizes, to win 500, I have 0.001 of the probability. For 248, 0.0001. For 148, that means 150, 0.001. For $73, which is the price of $75, but when you don't subtract 2, it becomes 73. It's 0.001. Now, how about the price of winning? I mean losing. How about the probability of losing? I have it here as 1,496 divided by 1,500. So that gives us here 1,496, okay, divided by 1,500. That gives us 0.997 if you round it to 3 decimal places, which is what I have here. So for you to lose the $2, the probability is 0.997. Now, we are ready to calculate the mean. So next thing is to multiply these two numbers here, this times that. So you can see x times the probability of x. So you're going to do this is our x, multiply this. So 498 times 0.001 give us this. I'm going to show you. 498 times 0.001 give me 0.498, which I have here. So I follow the same process for all of them, multiplying these two in each case to get all this. Then I add from here. So you can see once you add it with the calculator, you see that you have a loss of $1.03, which means that this number actually is a symbol that shows you that you usually lose. So now, expected value, which is the what we are looking for, which is the mean, is sum of x times the probability of x. This is x times probability of x. If you add them all, you get negative 1.03, which is what we have here, and a loss. So this means that this explains why in most time we lose when we buy a lottery ticket. So I wrote here that the answer shows that the expected value is negative, which basically represents a loss. Now, this is how we can apply the expected value to lottery situation. Now, I hope you enjoy the lecture and understand it. Now, remember, always if you have a question, please send a question through my YouTube channel to me about what I have taught already, and I'll get back to you as soon as it's possible for me. Now, let's see how we can apply the expected value calculations to business. Look at this. Now, a ski resort loses $70,000 per season when it does not snow very well, and makes $250,000 profit when it snows a lot. Now, this is an old data. Now they make millions of dollars. Sky resorts, they make millions of dollars now. But this is just to show you, example. Now, the probability that it will snow at least 75 inches, which is good for the ski resort, is 40%. Find the expectation for the profit. So in this case, let me just put in the profit. If it snows very well, he makes $250,000. And the probability is 40%, which is 0.4 right here. Now, if it does not snow very well, they lose $70,000, which is negative $70,000. Then the probability is 0.6. How do I got 0.6? Because the probability of making profit is 4.4. The opposite is 0.6, which is 1 minus 0.4. Here, 1 minus is 0.4. That's 40%. 0.4, which is 0.6. Another question that people might ask is, how do I get 0.4? Because it says that it is at the probability that it will snow at least 70 inches, 40%, which is the same as 0.4 when you change the percent to a decimal. Okay? Now let us do our work. We put them in the table. This is if he makes a profit, it's $250,000. If he loses, negative $70,000. Now the required probabilities are 0.4 for profit and 0.6 for loss. Okay. So we multiply the two. This times that give me this. 0.6 times negative 70,000 give me negative 42,000. So when you add these two, that gives me 58,000, which is positive. So because our answer is positive, we can say that it is a good business. Now, to answer the question, the expected value is summation of x times the probability of x. This is x times the probability of x, and if you add them, you get a positive 58,000, which is positive number. So whenever it is a positive number, it usually means that it is a good business, or I would say it's a profitable business. If you are able to figure out the real probabilities of success. Okay. Now, this is how I interpreted it. This is obviously a good business, particularly for that season, because the expected value is a positive number. I hope you enjoy this. Very good. Okay. Now, I'm going to try one more example on how to apply this to business, but I'm going to use a different method. Remember, I've been using the shortcut method, putting them in a tabular form. Some people might be asking me, how about the regular method, the horizontal method? So I'm going to do the same thing using a similar sort of equation using the horizontal method, which is, if I do it this way, I will get the same answer. Okay? It says here, calculate the expected monetary value for profit from crop yield. This is the weather, dry weather. It's a profit. This is the probability. These probabilities have been estimated by the agency who supplied this data to us. So in that case, since we are using we're not using a shortcut method, we're gonna multiply each of this times that, this times this, and this, and then add them. So 200 times 0.3 is right here, 200 times 0.3 plus 300 times 0.5, you can see right here, plus 150 times 0.2. So let me show you how this answer will come about. So we got in parentheses, okay, we got this here, 200,000 times 0.3. I got 200 times 0.3. I close the parenthesis, plus another parenthesis, 300,000 times 0.5, 300,000 times 0.5, plus 150,000 times 0.2. I got 150,000 times 0.2, which is this one, 0.2. Close it. Then I press my enter key to get the answer. So I got 240,000, which is the same thing we have here. Now, I hope you enjoyed this lecture. Please don't forget to subscribe to my channel so that you will always have access to new lectures. I'm going to leave you here for today. In my subsequent lecture, in my next lecture, I will introduce you to other discrete probability distributions. Okay? All right. You have a good day. Enjoy the rest of your day. Thank you. Bye-bye.